Hello everyone. In this video I will teach you um, an alternative formula to compute Vx. Well, let's start with what was the formula, or how we can compute variance of a random variable. Well, let x be a discrete random variable. That's what we work with in this chapter. And it has values, well, finitely many values, x1 up to xn, um, and um, and mu and the expected value mu. Then the way we computed this thing was this. Okay, so v of x is this number. You first value minus mu square, and then multiply it by probability of x being equal to x1 plus x2 minus mu square multiplied by probability of x being equal to x2, and then this continues up to xn minus mu square probability of x being equal to xn. Well, this formula, as you can see, has its own, well, the main definition is this, but there's other way of doing this. This is a fact. This is a new formula. Let me write as new formula. What does it say? It says that for a random variable, Vx can be computed in different way also. You can do e of x squared minus e of x squared. Let me do this. What is happening here? E of x squared, meaning that, well, you first find the e of x squared. I'll explain a little bit more on that, but then minus e of x, which is mu. So let me just write it in this other form also, e of x squared minus mu squared. So that is a new formula, and you will see in different form that you need to know this one. Let me just do one example which kind of needs this formula. Find sigma of x if it is known that mu is equal to 2, mu for x, and e of x squared is equal to, equals to 20. Well, okay, you may say, well, where is v? We were talking about v. Well, first thing to note is that if I have v, then the only thing I need to do is take a square root of that, and that is what we need, what we are asked to find. Okay, so but here I have e of x squared given. I know Vx is equal to this. Then I'll find square root and find sigma. And in this case, 20 is there minus 2 squared. So I have 20 minus, minus 4, and that's root 16. And root 16 is, not 8, just 4. Always standard deviation sigma x is always positive root of the variance. before I go, I just want to mention something. What is um, what is e of x squared? So we know what is ex, but what about e of x squared? Well, this is very nice to note that okay, you see x, when you have x, this basically is the table of values, and this is PDF. So you have x1, x2, and up to xn. Yes, and then you multiply each one by x1 square. What is square? Just f of x1, f of x2, and go down up to f of xn. This is just x itself, and we know what to do when we are trying to find ex. You multiply each number to the corresponding PDF value and then add them. But I'm not looking for ex, I'm looking for ex squared. Well, in this case, we have a new random variable whose values are the values of x, but square them, values of x, square them, values of x, score them. How about PDF? PDF is exactly same PDF as before. X1, x2, and xn. And then now it makes sense to say what is e of x squared. Well, you multiply x1 squared to x1 squared to f of x1, x2 squared to f of x2, xn squared to f of xn, and that will give you e of x squared. So let me just write this: f of x1 plus x2 squared, f of x2